Hello friends, today we are going to discuss spectrum point from the subject Foundations of Communication and Computer Network. Here, spread spectrum is designed to use in wireless applications such as LANs and WANs. In wireless applications, all stations use wireless media such as air or vacuum as a medium for communication. As like multiplexing, in spread spectrum, we combine signals from different sources to fit into a larger band. Goals of spread spectrums are to share medium, to prevent interception from an interference such as errors, and prevent jamming. To achieve these goals, spread spectrum techniques add redundancy into it. They spread the original spectrum needed for each station. If the required bandwidth for each station is B, then spread spectrum expands it to BSS such that BSS is always greater than B. Spreading process uses a spreading code and spreads the bandwidth. The spreading code is a series of numbers that look random but are actually a beat pattern called as pseudo noise sequence, that is PN sequence. Here in this diagram, same thing is noted. It spreads the original spectrum needed for each station. If the required bandwidth for each station is B, then spread spectrum expands this bandwidth up to BSS such that BSS is always greater than B. And the expanded bandwidth allows the source to wrap its message in a protective envelope for a more secure transmission. An analogy is the sending of a delicate, expensive gift. We can insert that gift in a special box to prevent it from damage during transportation. And we can use a superior delivery service to guarantee the safety of the package. Basically, there are two types of techniques for this spread spectrum, such as frequency hopping spread spectrum and direct sequence spread spectrum. In this video, we will go in detail with frequency hopping spread spectrum. The frequency hopping spread spectrum technique uses m different carrier frequencies that are modulated by the source signal. At one moment, the signal modulates with one carrier frequency, and at the next moment, the signal modulates with another carrier frequency. Then also the modulation is done using one carrier frequency at a time. Then M frequencies are used for long run. Then the bandwidth occupied by a source after spreading is always greater than the original bandwidth. That is B of FHSS greater than B. This diagram shows the general layout of frequency hopping spread spectrum. A pseudo-random code generator called pseudo-random noise creates a k-bit pattern for every hopping period of T of H. The frequency table uses the pattern to find the frequency which is to be used for this hopping period and then passes it to the frequency synthesizer. The frequency synthesizer creates carrier signal of that frequency, and then the source signal modulates the carrier signal. Suppose we want to have 8 hopping frequencies, then we can illustrate this by using simple example as shown in the figure. In this case, M is equal to 8 and K is nothing but 3. That is 3-bit pattern. The pseudo-random code generator will create 8 different 3-bit patterns. These are mapped to 8 different frequencies in the frequency table as shown in the figure. The pattern for this station is 101, 111, 001, 000, 010, 011 and 100. Here the pattern is pseudo-random after 8 hopping. That means the pattern repeats starting from 101 again. This means that at hopping period 1, the pattern is 101, that is 700. The frequency selected is 700 kilohertz as shown in this figure. For 101 pattern, frequency selection is 700. Therefore, the source signal modulates this carrier frequency as shown here. For frequency hopping period 1, 700 is chosen. The second K-bit pattern selected is 111. Second K-bit pattern selected is 111, which selects the 900 kilohertz carrier. The 8th pattern is 100. The 8th pattern is 100. That is, the frequency is 600 kilohertz. Figure shows how the signal hops around from the carrier to carrier. We assume the required bandwidth of the original signal is 100 kilohertz. If there are many k-bit patterns and the hopping period is short, then the sender and receiver can have privacy. If an intruder tries to intercept the transmitted signal, he or she can only access a small piece of data because she or he does not know the spreading sequence to quickly add up herself or himself to the next hop. The scheme has also as an anti-jamming effect. That means a malicious sender may be able to send noise to jam the signal for one hopping period randomly, but not for whole period. Next point is bandwidth sharing. How bandwidth is shared in frequency hopping spread spectrum. If the number of hopping frequencies is m, then we can multiplex m number of channels into 1 by using the same VSS bandwidth. This is possible because the station uses just one frequency in each hopping period. M-1 other frequencies can also use other M-1 stations. That means M different stations can use the same VSS if an appropriate modulation techniques such as multiple FSK is used. Here in this figure, FHSS and FDM is given, which are most probably similar. Here, figure shows 4 channels using FDM and 4 channels using FHSS. In FDM, each station uses 11 m of the bandwidth, but allocation is fixed. In FHSS, each station uses 11 of the bandwidth, but allocation changes hop to hop. We mention here some advantages of FHSS. It can be arranged to avoid portions of the spectrum, those occupied by other systems or affected by frequency field. It is relatively short acquisition time because the chip rate is considerably less in the frequency hopping system. No near or far problem present in this FHSS. Some disadvantages are mentioned. It required complex frequency synthesizer in order to generate frequency hops. It always requires error correction. only average power is spread, the narrowband interference is either eliminated completely or partially. As spread spectrum is designed to use in wireless applications, some wireless applications are mentioned here in which a frequency of spread spectrum can be used, such as wireless LANs, cordless phones, space communication, GPS, cell phones, personal communication system, wireless video cameras, as well as military applications. Okay, thank you.